3 of our Two Pint Problem series. We're here in the Allsop Arms pub, well known to some people who work for TelecomTV, very close by Baker Street, which is of course where Sherlock Holmes used to be, and that's why we're calling this the Two Pint Problem. I'm here with Lestrade, Ian Scales, and next to me Martin Taylor, CTO of Metaswitch Networks. Martin, welcome. You are Holmes. You look Holmesian. So I'm going to start by asking you, last time we were looking at SDN and NFV, particularly NFV. And I'd like to begin the discussion now, this time if I might, by asking you this. What sort of things will enterprises be able to do under SDN and NFV that they can't do now?
Well, I think that depends a little bit on what the operators choose to do with SDN in their networks. But in principle, what SDN allows them to do is to expose APIs that allow for very fine-grained control over what's happening in the network, the access network, even the core network potentially. And those APIs can support applications that will then deliver services that potentially are interesting to enterprises. Now, having a very programmable network, first of all, means it's much quicker to provision new services potentially, but also it opens the possibility of kind of self-service provisioning. So there's nothing to stop an operator with SDN deploying an application that can control the network, that exposes APIs or GUIs towards enterprises that allow them to, on demand, request capabilities from the network that they particularly need. Now, there are clearly lots of use cases that none of us are really going to know exactly what's going to get traction, but again, one of the benefits of having a more programmable network is that you can try stuff out. You can expose APIs, expose GUIs, and see what gets traction with enterprises, and experimentation, see what works, the things that don't, discard them, move on. That's the kind of benefit of programmability of the network.
And I suppose we're thinking about this on the way you phrased the question, Martin, was there were two sides, the customer and the telco. Yeah. But I suppose too there are third parties in this who might be cloud service providers, for instance, who also have kind of upstream access into the network to fit it out better for their end user clients in terms of the way the network responds to the applications that they're running. Do you see that as possibly the main way, Martin? Because I can't help thinking back to other attempts at this type of thing where you have interfaces that enterprises are supposed to be able to use. They don't really come off because often enterprises don't really want to get into that level of detail. But maybe a third party, would be the person, the entity that would provide that.
Yeah, I mean, that's certainly possible. Obviously, the network operator owns the facilities and the assets, and they're the ones who are in the driving seat as it relates to making SDN-style programmability available to third parties. Now, those third parties could well include cloud computing providers who then take advantage of those to help them deliver a better service to their enterprise customers. Some network operators who are offering cloud services themselves may choose to keep that SDN programmability as a differentiator for themselves. Some may recognize that third parties can do a better job of it. So I think we are going to see different flavors of decisions around what assets get exposed to what parties in this picture.
I know it's early days, and you're sort of sitting in these meetings and people are discussing things in quite an abstract way because we don't know how they're going to be used. But in your imagination, what applications do you see in that fulcrum between service provider, telco, and corporate end user? What sort of things are they going to be able to do that they haven't been able to do up till now?
Connectivity is the key thing. Connectivity comes with service level agreements around bandwidth and latency and that kind of thing. Being able to provide some fine-grained control over that and provide guarantees. But there's lots of value add that can be placed on top of that connectivity. In terms of firewalling and network address translation and the whole bunch of bits of software functionality that can be deployed around the network in an NFV sense that can add value on top of that basic connectivity.
And will it also be an opportunity for things like, we've been waiting a long time, I think, for real cloud-based services to come online. When you think about it, you and me started writing about this probably 6-7 years ago when these services were supposed to come online. We've got Salesforce.com, and we've got, what else have we got? Not much.
Not much else.
Not much else really. And I'm wondering whether this, this technology will provide a real spur for that to start happening, because now you've got cloud and telecom coming together in perhaps a really fruitful way, and you'll be able to deliver these online services more, more reliably and more responsively, with this technology giving you a kind of leg up for it.
Sure. I mean, so there are obviously some very visible cloud-based applications, software as a service applications like Salesforce.com. But you've got to remember that the cloud services, are all layers of the stack. So there are software as a service offerings. There are platform as a service offerings. Where you have individual building blocks for quickly creating applications. And then there's infrastructure as a service where it's just raw compute that you've got. And we're going to see offerings at all levels of that. Probably SDN and NFV are going to play more strongly in the platform and infrastructure as a service rather than necessarily in the software as a service space. But all sorts of things become possible when you've got this combination of SDN and NFV in the network. One of the things that we've been looking at particularly is the idea that you could offer IMS as a platform as a service offering. So, for example, a network operator could offer an enterprise the ability to create or instantiate a private IMS network just for that particular enterprise, and deploy on that IMS network the very specific voice applications and messaging applications and video calling applications that enterprise wants and needs. But that's a much, from the network operator's standpoint, that's a much safer prospect than allowing an enterprise to deploy all sorts of stuff on their public IMS. In effect, they can create a sandbox and allow the enterprise to do whatever it wants within that sandbox, but provide them with the basic building blocks. And IMS as a building block of those kinds of voice services, that's a platform as a service play that could be very interesting.
And for the same reasons, I suppose, too, there's an MVNO opportunity there too, isn't there, for people to get into the MVNO market relatively cheaply. Well, very cheaply, in fact. Well, we don't like the word cheap, but you know what I mean.
Yeah, potentially. I mean, we're now talking about, truly virtual network operators who, but virtual network operators in that environment can actually have got a lot more control over what's going on. I mean, the typical MVNO doesn't have anything at all. I mean, they're just totally dependent on the MVNE. But you can imagine certain sort of hybrid cases where the MVNO is getting the radio access network, but it is then deploying their own applications, perhaps in a cloud hosted by their MVNE.
Yes.
Yeah. But being able to differentiate the service much more than they otherwise could.
Yes, and presumably much less costly. Because this is worth dwelling on, I think, because in terms of your offering, for instance, there's an amazing statistic, isn't there, that you could support a single end user for a few cents a year.
Absolutely,
on the software. Now that is absolutely astounding when you think about how that might enable somebody to come to the table with an offer that simply wasn't available before because of on a cost basis and a kind of barrier for entry basis.
Sure. I mean, when we talk about a few cents per subscriber per year, telcos are normally amazed that that's possible.
Yes.
Yeah.
But then, when you look at over-the-top service offerings, where you're getting maybe a messaging service for $1 a year.
Yes.
Actually, those guys have business models that can make sense.
Yes,
because
exactly.
Their costs are similar, a few cents per subscriber per year.
Well, that's WhatsApp, isn't it? I think, what is it, $1 a year or something?
Exactly.
Like that. And they're probably making 90%.
300 million users.
Yeah.
I mean, it's not a very big company.
So that's an astounding kind of breakout business model that could take place there. A private IMS network, which you can run yourself as a large corporate. That's got to be something that's really quite revolutionary.
Last time, episode 2, we skirted around the issue of standards, and I'd like to come back to that, Martin and Ian, if we could, briefly. What effect, if any, could and should SDN and NFV have on the formulation of next generation standards for mobile?
I've heard it said that if we knew what we know today about virtualization and about SDN, that maybe the 3GPP standards would look a little different.
Yes, that's been said to me.
Yeah, I'm not so sure about that. I mean, the standards define functions and they define standardized interfaces between those functions. They don't define how you implement stuff.
No.
And the function, the logical separation of those functions, really is not driven by considerations of where you implement stuff or how you implement stuff. It's driven by considerations of sort of logical separation of stuff that's sort of logically different. And also, of course, the touch points where the standards bodies think that potentially network operators are going to want to pick and choose different products from different vendors.
Yeah.
So I'm not at all convinced that the standards bodies would set about anything fundamentally differently. Now, if you've got a set of standards, you can build products based on those standards using proprietary telco-style traditional architectures.
Yeah.
Or you can take exactly the same standards and the same specifications, the same interfaces, and you can build a web scale implementation that's, scale out, uses stateless processing elements, which is what we did with Project Clearwater. I don't think, we started out Project Clearwater, funnily enough, actually not paying any attention to the standards at all. We just said, well, apart from SIP, we said, okay, let's take as a given we've got SIP endpoints, and we want to build something web scale that they can communicate with and provide call control.
So you
and
took
applications.
no cognizance of standards whatsoever?
No, and then we said, okay, having built that and having got it to work successfully and at scale and so on, we said, okay, how are we actually going to sell this?
Yeah.
How are we going to make it viable for network operators to deploy it? And the answer is, well, you've got to make it look like something that they can understand and recognize. They understand and recognize IMS. So, if we were able to massage our implementation so it exposed the standard IMS interfaces around the boundaries of it, then they could drop it into the network, easily and hook it up to the various different building blocks, the home subscriber servers, the gateways, the application servers, and so on. And it wasn't hard to do. It really wasn't. So
what you said, what you discovered in a way was that IMS has a series of logical components which do different things, even though it was designed not for this environment, a virtualized environment at all, but for an old-fashioned IP network environment, for instance, where geography mattered. It all ended up being about the same, really, once you divided it all up and worked it out.
Yeah, fundamentally, the building blocks and the separation of those building blocks and the interface between them, that fundamentally makes sense. There's this core which is responsible for routing SIP messages between and among the various entities, application servers where the service value gets added, the home subscriber server which is a repository of subscriber data, the border elements that are providing security. It all makes sense in the abstract, and then whether you implement it in physical boxes or as pieces of virtual software, it's all the same.
So, ready to go with IMS then? Can you see it being, because it's virtualized, because it's much less expensive to deploy, much less lower barriers to entry for operators to get into the market and do it? As we said before, an enterprise could launch an IMS service for themselves. So, you could have lots of people getting in, maybe over-the-top players getting in and launching IMS services. Do you see that happening? Do you see a lot of people coming in? Do you see different applications for IMS coming about because of it?
Yeah, we do, yes, and that's partly because of the cost efficiencies, but also the open source angle has proven to be interesting. One of the things that we've seen happening is that Project Clearwater has been embraced by some of the leading players in the sort of open source and API and developer space. So organizations like Voxeo Labs, Tropo, and Telestacks, who run the MobiSense open source project, they've both started using Clearwater as their kind of home environment, if you like, for building their applications. And those are application servers that expose APIs that encourage innovation and development. And those are things that network operators are always saying they want more of in their network, but have traditionally found hard in the old world. Partly because IMS was so expensive, partly because it was hard to work with, and partly because they always got it from their traditional vendors who didn't tend to encourage that kind of innovation.
Yes. So there's new pricing models obviously that come with it as well. If you go and use Project Clearwater to do an IMS, you don't have the sort of same licensing issues and so on as you have.
That's true.
That's going to be very important.
You're not paying an upfront license fee, but if you want the reassurance of a support contract standing behind the Project Clearwater, then we make that available as a software subscription service.
Fundamentally the same, even though it's completely different.
We're running out of time, chaps. We've only got a couple of minutes, 2 or 3 minutes left, but I'd like to just go back a bit, if we could, Martin, to the role of open source, and you just mentioned it. Go into a bit more detail about it. Isn't there quite a degree of ambivalence about it?
Yes, we've seen some interesting views expressed on this. I mean, obviously, network software, or the software that powers the equipment that's out in the network, traditionally has not been open source. Far from it. And certainly, some of the network operators we've talked to, have got very mixed feelings about bringing open source into their networking somewhere or other. I mean, I actually heard it said, one network operator we talked to said, if Project Clearwater is open source, an open source IMS, over my dead body does it come into the network? And to which the response is, are you running Linux in your network by any chance? And to which the answer is invariably yes. And then you say, well, that's open source. And it's almost like they say, yeah, but that doesn't count. And and it's not quite clear why that they would view an operating system fundamentally differently from an IMS core, for example.
So what's the ambivalence based on? Is it suspicion? Is it concern?
Is it security?
Yeah, I mean, well, one of the concerns is the nature of open source licenses. So we license Project Clearwater under the GNU public license, and that's what they call a copyleft license. And what it means is that if you take Project Clearwater into your network, and then you make modifications to the code, if you redistribute the software, then you have to make available the source code for that.
Right.
And somehow or other, people get the idea that if they bring it into their network and make changes to it, then they just automatically have to publish those changes.
Right.
And the answer is, no, they don't, only if they redistribute the software. Now, network operators typically don't distribute software. If you bring Clearwater into your network and make changes to it that are personal to you and differentiate it, you don't have to publish that source code. As I say, unless you redistribute the software, network operators typically don't. So once they get their minds around that, and they get legal advice, obviously, then I think we'll get through that. But certainly within the ETSI NFV activity, there's a lot of focus on open source. I mean, a lot of the network operators believe open source is really important there, and particularly, for example, in the cloud management space. So projects like OpenStack, CloudStack, they're the ones that people tend to be homing in on, because. Well, I guess partly because people don't believe there's real differentiation in that software. It's kind of like the operating system of the cloud, so a little bit like Linux. It makes sense for that to be level playing field and to have a community behind it that continues to develop it. But people certainly do seem to be a little bit ambivalent about virtualized network functions themselves being open source. But I think we'll get through that.
Yes. And presumably they've watched IPR disputes and so on where could happen in the to them. The nightmare is that somebody comes out of the woodwork and raises a dispute over the open source code.
That would never happen, would it?
It might.
Well, yes. I mean, IPR obviously can be a thorny subject in the telecom space for sure. Yeah.
Absolutely. Well, we're out of time. I'm sorry, that's the end of episode 3 of the Two Pint Problem. I'd just like to thank Ian Scales. And of course Martin Turner from Metaswitch Networks. Great to see you, gentlemen, and cheers.
Cheers.
Good help, folks.